Hi, in today's video, we'll talk about matrix. What is a matrix? A matrix can simply be imagined as an arrangement of numbers. A, which has the members A, B, C, D. It's an arrangement of elements, and this is a matrix called 2 by 2 matrix. Another matrix B with elements A, B, C, D, E, and F is also a matrix, but this time it is a 3 by 2 matrix. How do you add matrix? Addition. But before addition, let's try and review or talk about some types of matrices. The plural for matrix is matrices. A square matrix should be either a 2 by 2, a 3 by 3, a 4 by 4. This side of a matrix is called the row, and this is the column. So in short, you can say a square matrix should have equal number of rows and columns. So a 2 by 2 matrix has 2 rows and 2 columns. A diagonal matrix is a matrix that has, it will be a square matrix anyway, and you have something like 2 and 3, any numbers aside zeros, but all other members apart from the leading diagonal. The diagonal with the right hand, if you try to make a diagonal with your right hand, is called the leading diagonal in matrix. This is the leading diagonal. The other matrix, as the name suggests, is called the other diagonal. Sorry, the other diagonal. A unit matrix is just like the diagonal matrix, but this time the leading diagonal has members 1, or elements to be 1. It should be a square matrix, just as before. So this is an example of a unit matrix. This is also another example of a unit matrix. Now we can move on to addition of matrices. To add matrices, assuming you have a matrix A with the members 2, 3, 4, 5, and another matrix B with the members 5, 6, 7, 8, and you are asked to find the sum of the two matrices. Simply add each matrix at the same position. So 2 has the same position as 5. You have 7. 3 has the same position as that. Then you have 9, 4, and 7. You add them up to get 11. 5 and 8 could be added to get 13. Subtraction of matrices also works the same way. Instead of adding, you just subtract. 2 minus 5 will give you minus 3. 3 minus 6 will give you minus 3. 4 minus 7 will give you minus 3. 5 minus 6 will give you minus 3 again. Then we move on to addition and multiplication of matrices. Multiplication. Multiplication, even though not very challenging, but it is just not straightforward as addition and subtraction. For multiplication of matrices, it is important that the first matrix and the second matrix you are going to multiply should have the same, I call it middle numbers. That's the column of the first one should be equal to the number of rows of the second one. For example, you can multiply a matrix 2, 3, 4, 5 by another matrix 2, 5. As you can see, this matrix has 2 columns and this matrix has 2 rows. That's the prerequisite for multiplication in matrices. How this is done: take this number here, you multiply that, and now you should know that our new matrix is going to take the form of the second, and take this, you multiply that and add the 2. So 2 times 2 is 4, plus 5 times 3, that's 15. 2 times, down here do the same thing, 2 times 4, that's 8, plus 5 times 5, which is 25. And now our resulting matrix is going to look like this: 19 up here, and is that 33? 33 down here. Okay, now let's try and multiply a 2 by 2 matrix by another 2 by 2 matrix. This is matrix A and matrix B. And we are required to multiply the 2 to find AB. Just as we did previously, take this one by one. It's most important that the number of columns here should be equal to the number of rows here. So take this column right here, use to multiply the first row here. So 2 times 2, we're going to get 4, plus, what did I write? Was that 3? Sorry, I can't remember what I wrote there, but let's just assume it's 3. Plus 3 times 2, that's 6. 3 times 4, sorry, that's 12. 12 of that. Okay. Down here, we are going to have 2 times 3, 6, plus 3 times 5, 15. Okay, now remember, our new matrix or our result should look like this. So what we are going to do is that we should have another column here. So that column should go like 5 times 2, which is 10, plus 4 times 4, which is 16. Then down here is going to be 5 times this 3, which is 15, plus 4 times this, which is 20. Our new matrix looks like this: 16, 11, 26, 35. With a few practice, you will master this. Next, we look at finding the determinant of the matrix. Finding the determinant of the matrix. Determinant. Determinant. Usually written as this of matrix A, or could be written this way, like sort of magnitude. To find the determinant of a 2 by 2 matrix, what you need to do is just multiply the leading diagonal as I spoke about earlier on, which is 10. 2 times 5 is 10. take away the product of the other diagonal, which is 3 times 4, 12, and the determinant of this matrix is negative 2. How do you find the determinant of a 3 by 3 matrix? For a 3 by 3 matrix, you first need to remember this: plus, minus, plus, minus, plus, minus, plus, minus, plus. Now, if you can reproduce this and you have any 3 by 3 matrix like 2, 3, 4, 5, 2, 3, 4, 2, 1, and we are required to find the determinant of this matrix, what you need to do is take any rule of your choice. Usually you take rule that will make your work as easy as possible. I recommend, if there is a rule that has 0, you always choose the rule that has 0, and pay attention to the signs. When you choose the middle rule right here, the first sign is negative, so I should start with a negative in the middle rule right here. Then I just take out all these as a column and a row that has the element I'm starting with, which is 3. So I'm left with, I have to write a 3 here. I will put it in a bracket for obvious reasons. Then that's if I should come across a negative. 5, 4, 3, 1. Now the sign should be positive. Luckily, since I have 0, I don't need to bother. Whatever I multiply by 0 is going to be 0, so I can just move on and have 2. After I check on the sign, it should be negative. Okay. Now for 0, I have to cross out this and that, and I would have written 2, 4, 4, and 1, but that wasn't necessary. So for the 2, I'm going to cross out this column that has 2 and this row that has 2. So I have 2, this 2, and this 5, and down here I have 4 and 3. Sorry, it looks like 25 and 43. So just, I can solve this now. As you can see, this is the determinant of this new created 2 by 2 matrix, which is 5 minus 12 plus 0. I'm just going to skip that and proceed to minus 2, and the determinant of this other newly created matrix will be 6 minus 20. Minus 3 times minus 7 plus 0 plus minus 2 times minus 14. I hope I got my calculations right. I have 21 here plus 0 plus, that's going to be positive, so positive 28. And the determinant of this matrix is going to be 49. Finally, finding the inverse of a matrix. When you are asked to find the inverse of a matrix A, the inverse is written this way, as in the reciprocal of A, or A raised to the power minus 1. So assuming you have the matrix 2, 3, 4, 5, to find the inverse of A, it becomes 1 over the determinant of A times the matrix, but in a fancy way. 2, 5, you negate the 4, you negate the 3. So the determinant of the original matrix here, that's 2 times 2 times 10, 2 times 5, which is 10 minus 12, so 1 over minus 2. Now let us multiply each side, and we have 1 minus 1, positive 2, sorry, just 2, minus 3 over 2, 5 over 2. And finally, you need to interchange the leading diagonal. So we negated the other diagonal, but the position of the members on the leading diagonal should also be interchanged. So instead of 1 here, I have minus 5 over 2 and minus 1 here. Then I have my 2 and minus 3 over 2 here. That is how you find the inverse of matrix. See you in our next video.